Right. We are now going to have a look at the exercises. Please take note. Please take note that you need to give reasons for all statements made. For all statements in questions 1, 2, and 3. So we are only going to have a look at. We are only going to do question 1, 2, and 3. Give reasons for all statements made in questions 1, 2, and 3. All right. Let's start with the first question. Question 1. 1.1. In the figure below. Here is our figure. In the figure below, RDS is a tangent to circle O at D. RDS is a tangent to circle O at D. O is the center, meaning O is our center, and point D is a point of tangents. If BC is equals to DC and angle CDS, which is this angle, is equals to 40 degrees. Calculate with reasons the measures of the angles in 1.1.1, 1.1.2, 1.1.3, and 1.1.4. All right. Now, before we answer the question we do 1.1.1 up to 1.1.4. First, have a look at your diagram. So I'm only going to do this one with question 1, but with each and every geometry problem that you solve, before you solve the question, read the statement carefully, understand the statement, and then from there go to the diagram and then take both the statement and the diagram, and then from there try to identify as many theorem statements as you can. So let me go back to the statement again. We are told that RDS is a tangent to a circle at what? At D. I'm already thinking about my tangent theorems. Tan-Cot theorem, will it work? Yes, Tan-Cot theorem will work. Angle D1 is equals to angle what? B1. Tan-Cot theorem. And what else? We are also having what? Another Tan-Cot theorem. From where? Angle BDS. Angle BDS will be equals to angle A. And we also have what? Another Tan-Cot theorem where we can say angle D5. Angle D5 will be equals to angle what? Angle ABD. Angle ABD. Tan-Cot theorem. Then tangent perpendicular to radius. Tangent perpendicular to radius. OD is a radius. We know that O is a center, RDS is a tangent. Therefore, it means what? It means ODS is 90 degrees. And also what? ODR, 90 degrees, reason being tangent perpendicular to the radius. Okay. Then they say if BC is equals to DC. BC is equals to DC. Therefore, it means what? When you look at triangle BDC, triangle BDC is what? Is an isosceles triangle. BC is equals to CD Therefore, it means what? Angle B1 will be equals to angle D2. Angles opposite equal sides. And angle CDC is equals to 40 degrees. Calculate blah. All right. That is what we got from the what? From the statement that we are given. But also, when we are analyzing our what? Our diagram. We have angle O1 at the center of the circle. And angle O1 is subtended by arc BD. And we see that also arc BD subtends angle A. Angle A at the circumference of the circle. Therefore, angle O1 will be equals to twice angle A. Angle at the center, twice angle at the circumference. That's the other theorem statement. The other one, you see that A, B, C, D is a cyclic quadrilateral. Therefore, opposite angles of a cyclic quadrilateral are supplementary. Angle A plus angle C will be equals to 180 degrees. And also angle ABC and angle ADC will be equals to 90 degrees. Please notice that in cyclic quadrilateral ABC, I only say angle A is equals to angle C because there is only one angle A and there is only one angle C. But when I'm talking about angle B and angle D in cyclic quadrilateral ABC, I need to be very specific because we're having what? We're having B1, B2, B3. We're also having what? ABC. Therefore, I need to be very specific to say which angle B I'm talking about. I'm talking about angle, let's go back to A and C. A is not equals to C, but rather angle A plus angle C is equals to 180 degrees. Opposite angles of a cyclic quadrilateral are supplementary. Then, coming back to what? To B and D. I can't just say angle B plus angle D is equals to 180 degrees because the question is which angle B am I talking about? Which angle D am I talking about? Angle D. Therefore, I need to be specific to say I'm talking about angle ABC, which is this angle. Angle ABC. Then I'm saying angle ABC plus angle ADC, which is which angle? Angle ADC, it will be this angle. ADC. Then I'm saying ABC plus ADC will be equals to 180 degrees. Opposite angles of a cyclic quadrilateral are supplementary. Okay. Which other theorem statement do I see? Center, tangent, tangent, cyclic quadrilateral, and also under the tips, no parallel lines, we have triangle. We have also identified an isosceles triangle. There are quite a number of triangles. What else? We have angle at the center, twice angle at the circumference. We are not having any angles in the same segment. So far, those are the only theorem statements that I can identify so far. But it is possible that you can identify even more. But after analyzing your diagram, you go to your statement, you go to your diagram, you analyze and identify as many theorem statements as you can. And then from there, that is when you can go to answering the questions. Then you will realize that as you are busy answering the questions, you have already answered those questions when you are busy analyzing your statement and the diagram that you are given. All right. Now let's go to 1.1.1, where we need to now calculate the measure of of angle BDC. Where is BDC? BDC, it is this angle. BDC, it is this angle, which is angle Angle D2. Then we see that angle D2 is equals to angle B1. We have already identified that D2 is equals to B1. Opposite angles opposite equal sides, because triangle BCD is an isosceles triangle. But now, how does that help us? We have angle B1, but we've also identified that angle B1 is equals to what? Angle D1. Tan-Code theorem. And D1 is equals to what? 40 degrees. Therefore, B1 will be 40 degrees. Therefore, D2 will be what? 40 degrees. Then you can say, okay. As I was busy analyzing by diagram, I had already actually what? Answered question 1.1.1. Then we can start first by saying angle B1 is equals to angle D1, and your reason being Tan-Code theorem. Remember, you must give a reason for each and every statement. Angle B1 here, B1 is equals to angle D1, Tan-Code theorem. Therefore, this means angle B1 is equals to 40 degrees. Then we say angle B1 will also be equals to angle what? Not B, but rather angle D2. Angle B1 will be equals to angle D2. Angle B1 is equals to angle D2. The reason is that these are angles opposite equal sides. Please make use of the what? Of the reasons that are there in your examination guidelines. Therefore, we can now conclude to say what? Angle D2 will be equals to what? 40 degrees, because B1 is equals to 40 degrees and B1 is equals to angle D2. All right, and then now question 1.1.2, angle C, the measure of angle C. Now we see that in triangle BCD, we know angle B1, we know angle D2, therefore it is possible for us to calculate angle what? Angle C. Because we already know here we are having angle B1 is 40 degrees, angle D2 is also what? 40 degrees. Then we can say angle B1 plus angle D2 plus angle C will be equals to 180 degrees. Reason, these are sum of angles in a triangle. Then what is B1? 40 degrees plus D2 40 degrees plus angle C is equals to 180 degrees. Then solve for angle C and then we get 100 degrees. 180 minus 80, 100 degrees. And then with 1.1.3, the measure of angle A. Angle C is now what? 100. So let's have 100 there. Then now angle A, we have already identified that angle ABCD, triangle quadrilateral ABCD is cyclic. We're having a cyclic quadrilateral ABCD and the opposite angles of a cyclic quadrilateral are supplementary. Therefore, we say angle A plus angle C will be equals to 180 degrees. Reason being opposite angles of cyclic quad. These are opposite angles of cyclic quad. Therefore, angle A plus 100 degrees is equals to 180 degrees then our angle A will be equals to what? 80 degrees. 180 minus 100. And then lastly, angle O1. Angle A is now 80. And then angle O1, we had already identified the theorem statement, angle at the center twice angle at the circumference. Angle O1 is twice angle A. Then we say angle O1 is equals to 2 times angle A. And the reason is angle at center is equals to 2 times angle at circumference. Then we say angle O1 will be equals to 2 times 80 degrees. Angle O1 will now be equals to what? 160 degrees. Okay, that is the end of 1.1.